Okay. All right. Um, what we're going to do here is I'm kind of leaving myself up here in the corner, and I'm hoping that I can. Okay, whatever. Okay, good. I got rid of that. Wanted to make sure I could get rid of that flashing there, but have me up in the corner too, best we can. So, uh-oh, now I'm completely gone. I'm probably behind. I want to be in front. I'll get it figured out here in a minute. There we go. And there we go. Because we were doing, oh, so I did it again. I did it again. Oh, there we are. All right. And I didn't want all that flashing around. Okay, so what we're going to do, Kaylee, is go through this real quick. All right. Because I didn't want it to be this hard. And it was. This was actually a pretty formidable assignment, and a lot of your classmates kind of so in the thing in the lecture we had the three types of frictional forces. I'll just say them. I'm not going to write them down, but there's the static where things don't move. In other words, if I have oh well, here's an example. Here's a quick, and I'll try and make this quick because I might have to make two movies of this because you don't want to have a checking the clock here about 1:31. You don't want to have these be much longer than 7 minutes or so. So if I have like this piece of chalk sitting on top of this uh, I can't remember what these are called, but they store a bunch of files, store all my files and stuff. So you can do that. Slide it. If you start to tip it, and then it slides. Okay, right now, static frictional force. Static, static, static. Then it goes to kinetic frictional force when it actually starts to slide. And then what we're doing in our lab is the viscous frictional force. Okay, now when your foot hits the ground, that is a that's if there's no friction there, as we found out when every Thursday we were having a snowstorm, sometimes you'd go outside and you'd slip and fall because you'd push off with your foot. You'd push back with your foot. You're going to push back with your foot, and then the static frictional force while your foot is planted is going to push you forward. All right, it's going to push your center of mass forward. Okay, so if the jogger here he's pushing to the right, and so the frictional force is going to push him to the left. Okay, and the same thing, the same concept. I keep wanting to scroll this, and there's no way to. It's a static picture on here, so I can have to move it manually. All right, the force that holds the car on the road when it makes a turn, or even to get it to go straight. The car on the road works this exact same way. Okay, works the exact same way, but it's a static frictional force because for a split second, just real quick, when a car is rolling, let's say the car is going this way, its axle velocity is going this way, then at the top, this is 2v, this is v, and at the bottom, it is equal to 0. The velocity is equal to 0. It's a weird thing, but that's the way things roll down the street. Otherwise, if there's no friction, they're just going to spin. Okay, and the axle speed will be 0, and if they're just spinning with no friction, then this is v, and this is v, and the axle speed is 0. Okay, all right, but anyway, all right. So if you place a heavy coin, there we go. So on your calculator, all you have to do here is this tangent of 22. Okay, and that'll give you whatever that'll give you the coefficient of kinetic friction for that object. All right. Okay, and then you just click on here and watch the curling video, and you can answer 5 and 6 and 7, I think, without much trouble. Yeah. Okay. So I don't need to go through those. Okay. This one caused a few problems with some of your fellow classmates. All right. Oh, this seems long, but it's really not. Okay, good. All right. I think starting this next part, we're going to go ahead and stop this nonsense. It's not nonsense, but we're going to stop this and we're going to go on to we'll make a second one.